Hi guys, this is another video in Cloud Insight series. In this video, I'm going to show you how to set up IPSec VPN tunnel between Azure to AWS using software-based VPN solution named OpenSwan. Alright, before we dive into the demonstration, I would like to give you a quick overview of the site-to-site VPN setup. Why do we need site-to-site VPN and what are all its use cases? I'll give you a quick overview on that. Site-to-site VPN tunnel is a network path over internet, the path which we use to connect from one network to another network using routers at both ends. The IPSec tunnel is a network protocol which provides a secure network transmission of network packets, doing encryption and decryption using a pre-shared authentication key between both the end of the connection. At both ends of the connection, we will be having routers to establish the connection. So what are the use cases? When do we use it? Like I said, it is used to connect to two different networks over internet. So this applies to any applicable scenario where you may have a data center which requires to connect to another data center across the geographical location or different countries, and connecting to your on-premises to your cloud resource over internet. That could be another scenario, connecting to one cloud provider to another cloud. It's not that you should stick with only one cloud provider. As a company, based on your requirement, you can choose, you can put your workload on multiple cloud providers and still make it work together by applying these solutions, right? Let's get to it. For this demonstration, I do have some setup. I'll show you. All right, for the demonstration, I have a VNet created in Azure in this CIDR block. Let's call it as a Mumbai site. VPC created in AWS in this CIDR block. For easy understanding, this is a site-to-site VPN demonstration, so I just named the site as Singapore. But actually, for considering the latency purpose, I have hosted the AWS VPC in Mumbai. If you look at the console, it will show you Mumbai. So regardless of the region, it still works the same. So hope you get it. Now, so in between what I have here, I do have a transit gateway created, and I have attached the VPC with the transit gateway. This VPC already have an internet gateway attached, and using which I'm able to connect to this management server. Likewise, over the internet gateway which is attached to this VNet, I'm able to connect to this OpenSwan appliance, which is based on CentOS virtual machine, right? And I'm going to start the demonstration. How it is going to work is that we need to install and configure OpenSwan application here. And in order to do so, we need to do some prerequisites preparation in the Azure VNet. We will be doing that, and then we will install OpenSwan. Then we will set up the routes, play around with the route table of the Azure VNet. Once we configure all of this, we will create a customer gateway from AWS. Based on the customer gateway, we will create a site-to-site VPN configuration, and then we will attach it with the transit gateway. And then finally, we establish the network routes. And once we start the IPSec tunnel configuration, once we start the service, the tunnel will be created based on the configuration created here from OpenSwan appliance to site-to-site VPN gateway over customer gateway. And this is the line which marked in red is your IPSec tunnel. That is why I have just shown you in a different color to differentiate from where to where the IPSec tunnel will be terminated, and then from where the network flows through the normal router. The transit gateway attachment is where it is terminating at the route table of the VPC, and the connection which I've shown over the internet. All right, let's get to it. Okay, I do have a resource group created called Mumbai, and I do have created VNet to machines and all of it. This is the CIDR block. And let's go to the virtual machine of the OpenSwan appliance. I call it as Mumbai VPN. I could have easily called it as OpenSwan VPN, but I just wanted to make you understand a little bit better. So using this public IP, I have already connected to this OpenSwan Mumbai VPN. All right. Likewise, I'm going to connect to the management server of this EC2 instance, which is hosted in AWS. All right. Now, what are we going to do? We need to prepare this OpenVPN appliance to install this OpenSwan application. There are a series of checklists. I'll put it in the description to make it easier for you to follow. Now, let's start from the IP address. Any software-based VPN appliance, it should have a public IP over to be able to reach it over internet, right? That is the public IP attached here. Important part is that it should be a static public IP. So in Azure, how do we change it? Click on the public IP and IP address assignment, make it static. Yes, this is the IP that is going to stick to it, and save it. Done. Next thing, go to the machine, networking, click on the network interface. The VPN appliance supposed to forward the network packets. It should be able to do the IP forwarding. By default, it's disabled for security reasons, and you must ensure that it is enabled before you start installing OpenSwan. You can even after installing OpenSwan, you can come back and enable it. It doesn't matter, but as a checklist, when you follow, just stick to it in the order so that you don't miss that. If you miss to enable this, what happens is the IPSec VPN tunnel might start, but you won't see the network flows through you through the appliance properly. All right, this configuration is done. And the next part, what we need to do, we need to ensure the OpenSwan appliance network security group allows a specific ports. So what are we going to do? Let's create a new network security group. Yes, let's create a new security group by VPN NSG. Yes, there is a network security group exist already. Let's use this. Yeah, this is a default one. Let's go to inbound rules. Let's hide the default rules. Now click on add. Okay, before that, I'll tell you what are the ports. It's all over UDP, port 500 and 4500. 4500 is another port. Let's create 500 first. The destination is the subnet where the appliance is created. Okay, you can think that keeping the source from any and destination any might work. Technically, theoretically it should work, but it doesn't. In cloud, if you want to establish a network connectivity, you can just specify it as any and you can expect it to work. No, you need to exclusively mention the IP address scope to ensure that the network path is created. All right. Now the source IP. What is our source IP? That is our VPC CIDR block. From AWS, we are going to connect. So in the AWS, copy the CIDR block of the VPC and paste it here. This is AWS CIDR block, and the destination. Again, mention the IP 10.1.0.0/16 is the CIDR block range of the whole VNet. So click OK. All right. Ensure you enter a proper name. Now AWS to Azure UDP 500. Create another rule. Again, the same. Source port 4500. Destination IP address 10.1.0.0/16. Again, the same port. Let's go to the virtual machine, networking, go to the network adapter, go to network security group, and select the security group name properly and save. All right. Now let's do refresh. All right. Now, if you look at it, you have the SSH22 port allowed, which we are connected from our laptop, from my laptop. The port, UDP port 500 and 4500 added, allowed from AWS Azure block. Okay. What happens if you don't create these two? When you create a customer gateway using this public IP, the configuration will not detect the appliance, the VPN software that is already installed. Based on that, the AWS auto-generates configuration file, right? If you don't provide it, okay, I will show you what happens when we create a VPN configuration. I'll show you why this is important. All right. What is next thing? Now let's create a route table. Okay, go to routes. All right, let's create a new route table. Choosing the resource group as Mumbai, region as South India. Mumbai VPN route table 01, Mumbai VPN RT 01. Yes, now it will create. Alright, the route table is created. Now let's see what are we going to do. Click on the configuration, propagate routes, yes, and let's add the subnets here. Virtual network Mumbai VNet, and then subnet. The default subnet is where our VPN appliance is created. I'm adding it. Okay, let's associate another subnet. Mumbai VNet is the VNet name. Mumbai A. I do have another Windows machine created in that subnet for a testing purpose. Let's see how the network works. Now route table. Add routes. Route name. What do we call it? Mumbai VPN RT01. Or okay, fine. IP addresses. Okay, let's call it as AWS to Azure. That is more appropriate. What is the IP address CIDR range of VPC? 172.25.0.0/16. What is our next hop? If the network connection coming from these address ranges, where it should route to? It should route to the VPN appliance. The VPN appliance's IP address is what it is asking for. Appliance, yes. Ensure you have IP forwarding enabled on your virtual appliance. You can enable this by navigating to the respective network interface IP address setting. That they have already done it, right? That is why I call it as a prerequisites that we really needed. And click on add. So now any network that is coming in to the AWS VPC's address range will be automatically goes through the VPN appliance. Okay, right, this is done. Let's create a new security group for RDP access. I do have another network security group, but it belongs to a different resource group, so I'm adding a rule to allow RDP connection from AWS address range. So what is the RDP port? 3389. The destination address, provide it to the whole site block 10.1.0.0/16 and destination port 3389 and over TCP and RDP. The name I'm making it as RDP from AWS, right? Hope this makes sense. Alright, I'm going to attach this network security group to the particular NIC. I think it's really good idea to attach this network security group to the whole subnet rather than attaching it with only one NIC. It is really better to have it for the whole network. Okay, how do we do it? VNet, virtual networks, Mumbai VNet. Go to the subnets. Mumbai A is one of the subnet, and network security group RDP from AWS. Yes, save, done. So far we have done all the prerequisites. This is done. I could have easily made all of this ready and then shown you, but I wanted to show the prerequisites also shown in the demonstration so that it is easier to follow. Now, what is the next thing that we need to do? In the VPC side, this is the transit gateway. From the VPC side, this is the transit gateway that I have created. Okay, the transit gateway attachment. This is the multi-cloud VPN demo attachment is the one we are going to use it. Okay, let's see the attachment. The attachment is already this attachment created for the VPC, which is here. Look at the resource ID. This is the one. From the VPC side, we need to do the network part. That is also comes under prerequisites. Go to route table of this VPC, the AWS side. We have already allowed the network communication from AWS to Azure by adding an entry into the route tables, right? The same thing is what we are doing it on the AWS side of it. Okay, so this is the route table of the particular VPC from AWS side. Go to routes and edit route. Now here we need to add the IP range of the Azure VNet, that is 10.1.0.0/16. and what is the target for this VPC? The VPC for this address ranges. What is the target for this VPC? For this VPC, the transit gateway's attachment will be the target. Okay, transit gateway and attachment. And if you don't understand this, I would strongly recommend you to watch the previous video which I have uploaded about how to use transit gateway and attach VPCs for communication. Right? If you watch it, you can understand it clearly. I'm attaching the transit gateway and click on save. So now the route from the VPC to this address range is updated from the AWS side as well. Is it done already? No. There is a route table for transit gateway as well. Let's go to that. This is the route table for the multi-cloud VPN demo transit gateway. The association, the moment we create an attachment and attach it with the VPC, and then that will be reflected here. Okay, and the propagations is by default enabled. Let's go to the route. This is the default route table of the transit gateway. Okay, and if you look at it, the CIDR block of the VPC that we have attached now is automatically listed here. How? Because it's propagated. We haven't created a manual entry here. We can still, if you want to add an entry, you can certainly create it here. Okay, we will see about that later. Okay, now AWS part is also done. The AWS side, we have created a transit gateway attachment and the route table entry is also made. As soon as we create the VPC attachment into the route table, so the transit gateway attachment entry in the route table, it automatically propagates in the route transit gateway's route table as well that we have seen. So what is next? We need to create a customer gateway, and using the customer gateway, we need to create a Site2Site VPN configuration. Is it the right order? No. Before creating the customer gateway, you need to ensure you have OpenSwan installed and ready to be configured. Okay, that is the next thing we are going to do. What is the first thing you need to do when you deploy a new instance? You try to update the appliance first, ensure all the updates are installed. Alright, the updates are completed. Now install OpenSwan. Install OpenSwan. Press Y to continue. Done. Now OpenSwan is installed. Now what is next? Now let's go to the AWS and let's create a customer gateway. So this will be your VPC dashboard and customer gateways. Create customer gateway, create a demo, like let's call it multi-cloud VPN. And BGP ASN, leave it default, you don't have to touch it. And this IP address is important. The IP address of the public IP address of the VPN appliance, which is this. Put it here, and we don't have any certificate ARN, so I'll leave it default. Leave everything default. Maybe device, maybe you can name it as OpenSwan. Create the customer gateway. By default it creates instantly, and you can see IPSec 1. And what is next? Now we need to create site-to-site VPN connection. Create VPN connection, AWS to Azure. Maybe what is our gateway type, which is a transit gateway, we have already created. That is what we are going to do. There are multiple ways you can do it. There are two ways you can do it. One is virtual private gateway, and another one is using transit gateway. The transit gateway is more efficient way of doing this, so I'm choosing transit gateway. And the customer gateway, which we have just created, which is this one. For the route options, choose static, tunnel IP version, keep it as IPv4, and we don't need acceleration. We can leave it default. We don't need to enable this acceleration. And here comes the important part, creating this VPN connection. The local IPv4 network CIDR, which is you need to enter the CIDR block of Azure 10.1.0.0/16, and the remote IP CIDR is AWS VPC CIDR block, which is 172.25.0.0/16. Okay. And the tunnel options, by default, the VPN, site-to-site VPN, creates two network tunnels. Okay, tunnel 1 and tunnel 2. It says optional. You can leave it to default. Let AWS to create a configuration for you, tunnel configuration for you. Create VPN connection. The VPN connection creation usually takes a bit of time, like 3 to 5 minutes hardly. So I will pause this video. I'll come back once it becomes active. Alright, the site-to-site VPN configuration has been created. Now let's download the configuration. Click on download configuration and you get this. Type OpenSwan here. It comes here because it is because in the network security group for the VPN appliance, we have already allowed for this 500 and 4500 over UDP, these two ports. If you don't do this before creating the customer gateway or before creating the site-to-site VPN configuration, the configuration download option doesn't give you the OpenSwan. Why I'm emphasizing is that I have done the mistake when I was learning and testing it before this, and got puzzled why the very first time when I tried the OpenSwan did came, and then I tried doing the same setup again just to recall my knowledge on that. I have missed the steps to create a network security group. I missed to add those two ports in the network security group for the OpenSwan appliance. And I have done everything right except that part. Because of that, what happened? When I tried to download the configuration for OpenSwan, it didn't provide one. Then later, I just figured out I should allow the UDP ports, the AWS to discover the device type and all. Then I realized it should be created already. I mean, the network port should be allowed before creating this VPN configuration. Only then we get OpenSwan. Okay, remember this. Now select OpenSwan, rest everything default. Click on download. I'm going to save it as OpenSwan, and let's open it. So this configuration also provides configuration details for two tunnels by default for redundant purpose. For considering the time that we are going to spend, I'm going to stick to the single tunnel. I'm going to create only one tunnel. I'm logging to the VPN appliance to root. All right, connected as root. Now let's see what all the configuration we need here. The beauty of this configuration file is that even if you don't know, or if you're doing it for the very first time, if you just stick to these instructions clearly, you will be able to set this up very easily without any hiccups. Okay. And step 1 for creating IPSec tunnel 1, it asking us to create these configurations in systl conf file. So let's copy this, and it shouldn't be having any spaces, so I'm just fixing the space before I edit the file so that it's easier for me to edit. We are going to edit, so I'm using Vim editor, etc ctl.conf, press I to insert, come back to the last row and copy this configuration, paste it. This configuration is for enabling IP forward over the network. Alright, escape :wq, done. And if you have a doubt whether it's written properly, just do a cat or right click, done. So it is updated. What is next? Apply the changes in the step 1 by executing sysctl-p. So copy the command, portal, okay, this is done. Second step done. Third, now we need to create the configuration for the IPSec. Let's see. Okay, let's read it first. Okay, it's always if you're doing it for the very first time, I would strongly recommend you to read every line. It says open this conf file and look for the line below. Ensure that the line in the hash in front of the line has been removed. Then save and exit the file. By default, what it is expecting is that this command, the command will be enabled already in this configuration file, and it is asking us to remove it. Copy the path. Before editing it, we can use the cat command to see whether we have that hash is enabled. Okay, if you look at it, include It's kind of, this is what it is suggesting, and it is not disabled. It is not commented out. It is already enabled. There is no hash available, so we don't have to edit and do it. So we are good in this part. The next one, we need to create tunnel 1. We need to create this configuration file. Copy. I'll clear the screen for you. Using Vim editor again, Vim space etc ipsec.d/aws.conf. Enter. Press I for insert and come back to this configuration file. Let's read this. This is the configuration for the tunnel 1. Okay, IPSec tunnel 1. Alright, I'll explain what this configuration is so that it is very easier for you to do it for the next time. Okay, what is this left ID? What is left side? Left is public IP of the OpenSwan appliance. Okay, this is the IP from the tunnel 1 of the site-to-site VPN that we have created from the AWS. Let's verify that. Go to the site-to-site VPN configuration and and go to tunnel details. And if you look at it, by default, AWS created 2 tunnels from AWS side, and this is the public IP of it. You got it? And there is an authentication which is given. I would recommend you to remove it because we are not going to use any encryption key authentication as such. So just delete this, and it is safe to delete, so don't worry about that. This left subnet is the CIDR range of Azure VNet, and the right subnet is the CIDR range of AWS VPC. This is what we need to manually enter to configure the tunnel. Okay, let's enter Azure VNet CIDR block here for the left. On the right, we need to enter AWS VPC CIDR block to establish the connectivity. Alright, this is done. Now copy the whole thing. Right click and go to the console. Now we are in the file, new file creation, right click, yes, AWS conf, escape, shift, :WQ. Now it is saved. The configuration file is saved. Let's go to the next step. For each tunnel configuration, we need to create one authentication secret file, and that is what we are going to do. Right click the name, enter, insert, and copy the whole thing. Paste it here. What is this IP? This is the public IP of the OpenSwan appliance. This one is the public IP of the tunnel that site-to-site VPN has created, and this is the pre-shared authentication key for the authentication purpose. So escape, W key, done. Now what we have done, we have configured tunnel configuration in the OpenSwan. Alright, now we need to restart the network to make these configuration to take effect. Okay, run these commands. Service space IPSec. Now we need to run some commands to restart the network and start the configuration. IPSec tunnel service space network space restart. Okay, it is done. Now we need to enable this IPsec service automatically starts along with the system. So we need to run this command chk check config space IPsec space on, enter. This is done. Now let's start it. Service IPsec start. Service IPsec status. Okay, service is active and it is running. So how do we verify whether our tunnel configuration is successfully connected? Go to Site2Site VPN configuration, and by default it loads details. Click on tunnel details and refresh it here. I believe it takes quite a bit of time, like 3 to 5 minutes hardly. So I'm going to pause this video until it comes up. So the tunnel is up. So I was waiting for quite a bit of time, and what happened was the tunnel was not up, and I was inspecting on both the side the configuration, and I discovered I made a very bad mistake while creating the site-to-site VPN configuration, which is while creating this site-to-site VPN connection from this end, I have given the IP address of AWS CIDR as wrong. Instead of 172.25.0.0, I have entered 172.15. That's a typo. So, but however, when we downloaded this configuration, and luckily this side right side subnet was actually it was manually entered. It wasn't it wasn't auto generated, right? So the configuration part on the OpenSwan Appliance side, that was everything set right, okay. But on the configuration side and the other side of the tunnel, which is AWS side, wasn't right, because the CIDR block was redirecting to completely a different CIDR range from what OpenSwan is establishing for, right? That is why the tunnel wasn't up. So this is a very simple typo, which very lame mistake could cause you this kind of an outage, right? In the real world, if you do this, then it's an escalation. So consider typing the IPs very carefully. So it's good that it's caught up in this demonstration, so that it'll be easy. It'll be a good reminder for you when you do it in the real world. Okay. All right. So the tunnel is up. That means it's a good sign. And the status is it's still modifying. That's okay. Yeah, it came up. Right. Now what do we need to do? We are almost done. We set everything up. Now it's testing time. All right. Now let's check whether we are able to ping the resources from Azure. First, I'll try to ping the VPN appliance, which is 0.5. Yes, it is responding. And we will not be able to ping other machines. I do have a client machine that is I've created. Since we haven't enabled the ICMP rule in the network security group, for the other machines I don't think it would work, but instead we can try RDP to the Windows machine. I'm going to take RDP of the Windows server running in Azure. That private IP, I'm going to get it, which is 6. Yes, I'm going to, we are prompted the authentication for the RDP connection, okay? That means the connection is working. I do have another account created. Yes. All right. As you see, this is Mumbai client. So this is the host name that I gave while I'm creating this VM in Azure. This is it. So we have completed the demonstration successfully. Hope you now you have a good understanding how site-to-site VPN works. Let's do a quick summary. So we created OpenSwan appliance and attached a public IP, made it static. We changed the network adapter of this OpenSwan appliance to enable the IP forwarding, and later we have updated the appliance and installed the OpenSwan appliance. For the network group attached to the network adapter, we added a rule to allow UDP port 500 and 4500 to establish the connection between the customer gateway and OpenSpan. And once it's done, the next what we have done, we have created a customer gateway using the public IP of this OpenSwan. Next, we have created site-to-site VPN connection using the customer gateway and provided the customer gateway. While creating the customer gateway, what we have done, we have given the network ranges of Azure VNet CIDR block for the left side network and AWS VPC CIDR block for the right side network, and created the configuration. Once the VPN configuration is ready, we downloaded the script and followed the configuration file for the tunnel, and we have created IPSec tunnel in the OpenSwan, and we saw the tunnel was established. The tunnel was up in the console, and later we have connected to the jump server from our laptop, and then established the RDP connectivity to the client machine through this tunnel using the private IP of this client server. All right. I hope you would have enjoyed this, and hope I was explaining it in a better way. Please subscribe to this channel. In this series, we are going to see a lot of real world scenarios. I'm going to spend a lot of time in creating these videos, and so please do subscribe and support us. Thank you.